Sa TVKASYON.
Hello there! I'm your teacher Kim. Welcome to a whole new learning experience. I'm sure you had a great time studying your previous lessons. This is Module 2 of Quarter 1, Lessons 1 to 3 in Mathematics Grade 10. In this module, the most essential learning competency is illustrate an arithmetic sequence. At the end of this video lesson, you will be able to define arithmetic sequence, identify the succeeding term in the sequence. Also, you are expected to determine the common difference of an arithmetic sequence. Write the first 5 terms of a sequence. And lastly, generate a general term of the given arithmetic sequence. Now, go grab your pen, your notebook and module, and let's get started. Previously, you have learned about patterns that are present in sets and in numbers. Now, let us try to look back and check how far have you understood the concept about patterns and sequence. Take a look at how these figures are arranged. Were you able to identify the succeeding figures? Is there a noticeable pattern in it? Well, if I were to answer, the succeeding figures would be similar to the first 5 figures. Now, consider this set of numbers: 0, 5, 10, 15, 20, 25, 30. What would be the next 3 terms after 30? Notice that each term after the other increases by 5. So the next 3 terms would be 35, 40, and 45. Do you have the same answer as mine? I suppose you got it correctly. Sequences usually have patterns that allow us to predict what the next term might be. You have also learned how to express sequences recursively and explicitly. Now, consider these sets of numbers and try to match these with the pattern stated on the right column. Which among the patterns is applicable to the sequence in number 1? It is the pattern in letter B. We add 9 to the previous term to get the succeeding term. 3 plus 9 gives us 12, 12 plus 9 gives us 21, and 21 plus 9 gives us 30. How about in number 2? It is the pattern in letter D. Simply divide the previous term by 3 to get the succeeding term. 81 divided by 3 is 27, 27 divided by 3 is 9, and 9 divided by 3 is 3. What about the pattern that pertains to the sequence in number 3? It is the pattern in letter A. Subtracting 7 from the previous term will give us the succeeding term. 35 minus 7 gives us 28, 28 minus 7 gives us 21, and 21 minus 7 gives us 14. Lastly, what pattern identifies the sequence in number 4? It is the pattern in letter C. Multiply the previous term by 2 to get the succeeding term. 10 times 2 is 20, 20 times 2 is 40, and 40 times 2 is 80. And now, you're on your way to learn more about patterns and sequences, particularly arithmetic sequence. So what is an arithmetic sequence? An arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. What does it mean? Well, take a look at this set of numbers: 9, 16, 23, 30, 37. Is there a noticeable pattern in it? How are the terms related to one another? Well, the pattern in this sequence tells us that the succeeding term are obtained by adding 7 to the previous term. 9 plus 7 is 16, 16 plus 7 is 23, and 30 plus 7 is 37. You see, we constantly add 7 to every term. This constant is what we call the common difference of the sequence. By the way, what do we mean by common difference? The common difference is the constant amount of change between numbers in an arithmetic sequence. Actually, we can easily identify the common difference by subtracting the previous term from the succeeding term. 16 minus 9 equals 7, 23 minus 16 equals 7, 30 minus 23 equals 7, 37 minus 30 equals 7. Notice that the amount of change between the numbers is the same. Thus, it is called the common difference of the sequence. Since every term in the sequence is obtained by adding a constant called the common difference, the sequence 9, 16, 23, 30, 37 is an example of an arithmetic sequence. To better understand what do these terms mean, check this out. Let us compare the two sets of numbers and try to identify which between them is an arithmetic sequence. Remember that each term in an arithmetic sequence is obtained by adding a constant called the common difference. It means that the sequence should have the same differences between the terms. You have 10 seconds to answer this. Time is up! Do you have your answer now? Let's see if you got it correctly. Let's start with the first set of numbers. 18, 26, 34, 42, 50. 26 minus 18 equals 8. 34 minus 26 equals 8. 42 minus 34 equals 8. 50 minus 42 equals 8. For the second set of numbers, 1, 2, 4, 8, 16. 2 minus 1 equals 1. 4 minus 2 equals 2. 8 minus 4 equals 4. 16 minus 8 equals 8. Since the difference between the terms in the first set of numbers are the same, while the difference between the terms in the second set of numbers vary, we can now say that between the two sets of numbers, 18, 26, 34, 42, 50 is an arithmetic sequence. Sequence is a pattern of numbers where order matters. Now, I will be writing the first 5 terms of an arithmetic sequence, written in general form. Given the arithmetic sequence, a sub n equals negative 3n plus 5, remember that a sub n denotes the term position in the sequence. Basically, I will be looking for the values of a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. To get the first 5 terms, I will substitute the values of n, then do the calculations. Using the general form, a sub n equals negative 3n plus 5. For the first term, where n is equal to 1, we write a sub 1 equals negative 3 times 1 plus 5. Negative 3 times 1 equals negative 3 plus 5 equals 2. For the second term, where n is equal to 2, we write a sub 2 equals negative 3 times 2 plus 5. Negative 3 times 2 equals negative 6 plus 5 equals negative 1. For the third term, where n is equal to 3, we write a sub 3 equals negative 3 times 3 plus 5. Negative 3 times 3 equals negative 9 plus 5, negative 4. For the fourth term, where n is equal to 4, we write a sub 4 equals negative 3 times 4 plus 5. Negative 3 times 4 is negative 12. Plus 5, we have negative 7. For the fifth term, where n is equal to 5, we write a sub 5 equals negative 3 times 5 plus 5. Negative 3 times 5 equals negative 15. Plus 5, we have negative 10. Looking at the calculations, we can now say that the first 5 terms of the arithmetic sequence a sub n equals negative 3n plus 5 are 2, negative 1, negative 4, negative 7, and negative 10. Let's have another example. Write the first 5 terms of the arithmetic sequence a sub n equals 4n minus 9. Using the general form, for the first term where n is equal to 1, we write a sub 1 equals 4 times 1 minus 9. 4 times 1 equals 4. Minus 9, we get negative 5. For the second term, where n is equal to 2, we write a sub 2 equals 4 times 2 minus 9. 4 times 2 is 8, minus 9, we get negative 1. For the third term, where n is equal to 3, we write a sub 3 equals 4 times 3 minus 9. 4 times 3 is 12, minus 9, we get positive 3. For the fourth term, where n is equal to 4, we write a sub 4 equals 4 times 4 minus 9. 4 times 4 is 16. Minus 9, we get 7. For the fifth term, where n is equal to 5, we write a sub 5 equals 4 times 5 minus 9. 4 times 5 is 20. 20 minus 9 is 11. Looking at the calculations, we can now say that the first 5 terms of the arithmetic sequence a sub n equals 4n minus 9 are negative 5, negative 1, 3, 7, and 11. Remember that a sequence could either be finite or infinite. So now, it is time to generate or write a general term of the given arithmetic sequence. An arithmetic sequence is actually a linear function y equals mx plus b. But instead of using this form, we will use a sub n equals dn plus c, where a sub n denotes the term, d denotes the common difference, n denotes the term position, and c denotes the constant. For example, write the general term of the arithmetic sequence 6, 9, 12, 15, 18. From the given sequence, we know that a sub 1 equals 6, a sub 2 equals 9, a sub 3 equals 12, a sub 4 equals 15, and a sub 5 equals 18. The 3 dots suggests expanding the sequence by generating terms infinitely. To write the general term of this arithmetic sequence, I have to identify the values of the common difference and the constant. To easily do this, I will be using the first term as my reference. Doing so, I can substitute 1 to n. Given that we have an arithmetic sequence, we can get the value of the common difference using any 2 consecutive terms. Subtracting the first term from the second term, we write d equals 9 minus 6 equals 3. Substitute 3 to d, we get a sub 1 equals 3 times 1 plus c. Now, I can substitute the value of a sub n and solve for the value of the constant using the addition property of equality. Add negative 3 to both sides of the equation. and doing so, I got 3 as the value of the constant. Using the values of D equals 3 and C equals 3, let us check if we can generate the second term of the given sequence. Plugging these values to the formula, A sub n equals Bn plus C, where n is equal to 2, D is equal to 3, C is equal to 3, we write A sub 2 equals 3 times 2 plus 3. 3 times 2 is 6 plus 3. A sub 2 equals 9. Looking at the calculations and using the values of the common difference denoted by D and the constant denoted by C, we can say that the formula works in generating the succeeding term of the sequence. Thus, the general term of the arithmetic sequence 6, 9, 12, 15, 18 is A sub n equals 3n plus 3. Now, let's have another example. Write the general term of the arithmetic sequence 13, 25, 37, 49, 61. Take note that the general term of an arithmetic sequence can be written in the form A sub n equals Bn plus C, where A sub n denotes the term, n denotes the term position, D denotes the common difference, and C denotes the constant. It means that we have to identify the common difference and the constant. How to get the common difference? We simply subtract the previous term from the succeeding term, using 25 as the succeeding term and 13 as the previous term. 25 minus 13 is 12. Thus, the common difference is 12. Plugging this value to the formula will give us A sub n equals 12n plus C. To get the value of C, we will use the first term denoted as A sub 1 equals 13. Doing so, we have 13 equals 12 times 1 plus C. To solve for the value of the constant, we will use the addition property of equality. Add negative 12 to both sides of the equation and continue with the calculations. Doing so, we now have 1 as the value of C. Looking at the calculations and plugging the values of the common difference D equals 12 and the constant C equals 1, we can say that the general term of the sequence 13, 25, 37, 49, 61 is A sub n equals 12n plus 1. You may also try to generate the remaining terms to check whether the general term is correct. Be reminded that upon writing the general term of an arithmetic sequence, I suggest you use the first term as your reference, then generate the remaining terms to check if you got it correctly. Good job, everyone! We're finally done with the discussion. I know you understood the lesson. I'm sure you did. Learning the concept about arithmetic sequence enables us to understand things with the use of patterns. And with this, we can create ideas and be systematically knowledgeable. Before you proceed to the evaluation, remember that 1. Arithmetic sequence is a sequence of numbers in which each consecutive terms have a common difference. 2. The common difference is the constant amount of change between numbers in arithmetic sequence. 3. We write the first 5 terms of an arithmetic sequence given its general term by substituting the values of n. And 4. The general term of an arithmetic sequence is written in the form A sub n equals Dn plus C, where A sub n denotes the term, D denotes the common difference, N denotes the term position, and C denotes the constant. To practice your skill from the lesson presented, I want you to answer the following questions. You have 10 seconds to answer each item. Enjoy! Number 1. What number is added every after each term to obtain the next term of the sequence? -9, -4, 1, 6, 11. A. 7, B. 6, C. 5, or letter D. 4. The answer is C. 5. Because adding 5 to every term gives us the value that is equal to the succeeding term. -9 plus 5 is -4. -4 plus 5 is 1. 6 plus 5 is 11. Therefore, the answer is 5. Very good. Number 2. Which among the sets of numbers is an arithmetic sequence? A. -3, 0, 4, 7, 11. B. 1, 3, 5, 7, 9. C. -3, 5, 11, 13, 15. Or letter D. 1, 5, 11, 13, 15. The answer is B. 1, 3, 5, 7, 9. Because every pair of consecutive terms has a common difference of 2, while the sequence in letter A, C, and D has no common difference among the pairs of its consecutive terms. Thus, the answer is B. Good job! You're doing great! Number 3. What is the common difference in the arithmetic sequence -15, -4, 7, 18, 29? A. 9, B. -9, C. 11, or letter D. -11. The answer is C. 11. Why? Because if you keep on subtracting the previous term from the preceding term, you get 11. Fantastic! Keep going! Number 4. Find the first 5 terms of the sequence A sub n equals 4n plus 1. A. 5, 10, 15, 20, 25. B. 5, 9, 13, 17, 21. C. 4, 8, 12, 16, 20. Or letter D. 4, 6, 8, 12, 14. The answer is B. 5, 9, 13, 17, 21. Substituting the values of n, 1, 2, 3, 4, 5 to the equation will give us 5, 9, 13, 17, and 21. Well done! Number 5. Which of the following sequences follows the general term A sub n equals 3n minus 2? A. 4, 8, 12, 16, 20. B. 3, 6, 9, 12, 15. C. 2, 4, 6, 8, 10. Or letter D. 1, 4, 7, 10, 13. The answer is letter D. 1, 4, 7, 10, 13. Why? Because if we do the calculations by substituting the values of n, we get 1, 4, 7, 10, and 13. Excellent! Wow! Congratulations! I am proud of the way you worked today. You have demonstrated your understanding on arithmetic sequence very well. Give yourself a hand for a job well done. Life is a series of events that could either break us or make us. Whatever it may be, just try to keep up with life and move on a constant speed, on your own pace, and know that life is about progress. And that ends our session for today. I hope you had a great time and learned a lot from this video lesson. See you on the next episode. Thank you for watching. Keep safe and enjoy the rest of the day. Sulong edukalidad.